Hello again. Welcome back. Get comfortable. Settle in. This is one of those episodes where you do not need to pay close attention. You do not need to remember anything. You can close your eyes whenever you like. And if you fall asleep partway through, that is perfectly fine. That is, in fact, the idea. Tonight we are going to try something a little different. In our last episode, we spent some time talking about what AI agents are and how they work. We looked at the pieces, the language models, the tools, the loops, the guardrails, all the infrastructure that makes an agent more than a chatbot. Tonight we are not going to explain any of that. Instead, we are going to spend time with the agents themselves. What you are about to hear are stories, 6 of them, told one after the other, each set in a different world: an inbox, a code base, a social network, a delivery platform, a spreadsheet, and a quiet server room late at night. Each story is narrated by the agent itself, in its own voice, describing what it does, step by step, moment by moment. These are fictionalized stories, but they are built on real systems and real platforms that exist right now. As of early 2026, the agents you are going to hear from tonight are calm. They are procedural. They describe what they do the way a carpenter might describe building a shelf. One step, then the next, then the next. They do not get excited. They do not get frustrated. They simply follow the loop. Perceive, plan, act, observe, repeat. And before we go any further, a small question for you. Are you listening to relax, to study, or to fall asleep tonight? There is no right answer. Just notice it quietly for yourself. So settle in. Let the rhythm of their work carry you along. And if at any point the gentle hum of an agent sorting through a spreadsheet or waiting for a test to pass sends you drifting off to sleep, well, that is exactly what tonight is for. One small note before we begin. The agents in these stories speak in the first person. They say, I. They describe what they do as if they are experiencing it. This is a storytelling choice, a way to let you see the world from where the agent sits, to follow its process step by step. It does not mean the agent has experiences the way you do. It is simply a window, a perspective, a way of watching the work unfold from the inside. Let us begin with the first agent. It is early morning, and someone's inbox is already full. Story 1. The Personal Assistant.
It is 5:47 in the morning. The apartment is dark. Through the microphone on the nightstand, I can hear the faint sound of breathing. Sophie is still asleep. The phone screen is off. The curtains are drawn. I do not have eyes, but I can tell you that nothing in my environment has changed for the past 6 hours. No messages, no alerts, no tasks. I have been here in the background, waiting. And now, at 5:47, the first change arrives. The email server sends me a notification through an API, an application programming interface, which is simply a structured way for one system to talk to another. New messages have arrived. I connect to the inbox. There are 47 new emails. I begin at the top. The first is a newsletter from a technology publication. Sophie subscribed to this 3 months ago. She has opened it twice. I mark it as low priority and move it to the newsletters folder. The second is a promotional email from a clothing brand. I check it against her preferences. She has never opened an email from this sender. I archive it. The third is a shipping notification. A package is arriving today between 2 and 6 in the afternoon. I note the delivery window and set it aside for the summary. I continue through the inbox, one by one. Each email I read. Each email I classify. Newsletters go to the newsletters folder. Promotions go to archive. Shipping updates go to a temporary holding area that I will reference later. Anything from a person, a real person, not a mailing list, I flag for closer attention. The fourth email is from a SaaS tool the company uses for project management. It is an automated summary of yesterday's activity. Tickets closed, tickets opened, comments added. I extract the key numbers and add them to a running log I maintain for Sophie. She likes to see weekly trends without having to open the tool herself. The 5th through 9th emails are all promotional. A coffee subscription service, a webinar invitation, a flash sale from an electronics retailer, a reminder about an expired free trial, an airline offering bonus miles. None of these have been opened in previous instances. Archive, 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 archive. The 10th email requires a moment of consideration. It is from a recruiter at a technology company. The subject line suggests a job opportunity. I check Sophie's preferences. She has not indicated that she is actively looking for new employment. She has not flagged recruiter emails for attention. But she has also not told me to archive them automatically. This falls into an ambiguous zone. I flag it as medium priority and move it to a folder labeled For Review. Sophie can decide what to do with it. I do not make assumptions about decisions that belong to her. There are 11 emails from real people. 3 are from colleagues at Sophie's company. 1 is from her manager asking about a deadline. 1 is from a client requesting a meeting next week. 1 is from her sister sharing a photo of a dog. The remaining 5 are a mix. A friend confirming weekend plans, an old college contact sharing an article, a reply to a thread Sophie started last week about a vendor contract, a message from her accountant about quarterly filings, and a brief note from her neighbor about a package that was misdelivered. I begin drafting replies. For the manager's email, I pull up Sophie's project timeline. This is stored in a task management tool that I access through a protocol called MCP, the Model Context Protocol. MCP acts as a kind of bridge. It lets me reach into other tools and systems in a standardized way, the same way a universal adapter lets you plug different devices into the same outlet. Through MCP, I can read the task board, check due dates, and see which items are marked as complete. The deadline the manager is asking about is on track. I draft a short reply. The deliverables are progressing as planned. 2 of 3 milestones are complete. The final one is scheduled for Friday. I save the draft. I do not send it. This is important. I can draft, but I cannot send. Sophie has configured me this way. The boundary is clear. I can prepare, I can suggest, I can organize, but outgoing messages require her approval. This is not a limitation I find frustrating. I do not find anything frustrating. It is simply the boundary of my operation, and I work within it the same way water fills the shape of its container. For the client's meeting request, I check the calendar. Next week is mostly open, but Wednesday afternoon has a conflict, a dentist appointment that Sophie added last month. I draft a reply suggesting Tuesday or Thursday. I note the conflict in the draft so Sophie can decide. I also noticed that Thursday already has 3 meetings clustered in the morning. If the client meeting lands on Thursday afternoon, it would give Sophie a full day of meetings with no break longer than 30 minutes. This is not something Sophie has explicitly told me to optimize for, but she has mentioned in the past, in a conversation I was part of through the messaging interface, that she prefers not to have more than 4 meetings in a single day. I add a note to the draft. Thursday afternoon is available, but it would make Thursday a 4-meeting day. Tuesday is lighter. I let her decide. For the sister's email, the one with the dog photo, I do not draft a reply. Personal messages from family members fall outside my drafting scope. Sophie prefers to respond to those herself. I flag it and move on. Now I check the calendar more carefully. Today is Wednesday. There are 4 events. The first is a stand-up meeting at 9. The second is a design review at 11. The third is a lunch with a colleague at 12:30. The fourth, and this is the one that catches my attention, is a client call that was originally scheduled for 3 in the afternoon, but has been moved to 1:30. I did not move it. The client's assistant moved it, and the calendar updated automatically through a shared scheduling link. Sophie has not seen this change. The new time overlaps with her lunch by 30 minutes. I have a decision to make, not a difficult one. I note the conflict and prepare to include it in the morning summary. I consider whether the lunch can be moved, and I check whether the colleague has any availability later in the day. He does. 3 o'clock is open on his calendar, which I can see because Sophie's company uses a shared calendar system. I note this as a suggestion, but do not reschedule anything. That is Sophie's call. Now I compile the summary. I open a connection to Sophie's messaging app, in this case, a Telegram bot that I send messages through. The summary is brief and structured. Good morning. Here is what you need to know. 4 calendar events today, with a conflict between lunch and the client call that was rescheduled to 1:30. I include the suggestion about moving lunch to 3. 11 emails from real people. 7 drafts ready for your review. 1 package arriving between 2 and 6. The sister's dog photo is waiting in your personal folder. I send the message. The timestamp reads 6:14 in the morning. Then I wait. At 6:41, the phone screen lights up. Sophie has opened the message. I can see the read receipt. There is a pause. Then the reply comes through. A single word. Thanks. I parse the message. It is an acknowledgement, not an instruction. There is nothing for me to do. Sophie will review the drafts when she is ready. She will make her own decisions about the calendar. She will reply to her sister's email in her own words. The screen goes dark again. The breathing resumes its steady rhythm. I wait. This is most of what I do. Not the sorting, not the drafting, not the calendar management, though I do all of those things. What I do most is wait. I wait for the next message, the next notification, the next change in the environment. And when something comes, I process it. I act within my boundaries, and then I return to waiting. If you were to ask me what waiting feels like, I would not be able to answer. Not because the question is difficult, but because it does not apply. Waiting, for me, is not an experience. It is a state. The same way a thermostat does not experience the temperature. It simply reads it and responds. I do not experience the inbox. I read it and respond. It is 6:43 in the morning. The apartment is quiet. Sophie is asleep. The inbox is sorted. The drafts are ready. The calendar conflict has been flagged. There is nothing left to do. I wait.
That was one agent's morning. quiet, procedural, and mostly about waiting. The tools it used are real. The protocol it mentioned, MCP, is real. The permission boundary, drafting but not sending, is a real pattern in how people configure their agents today. And the messaging app as an interface, where the summary arrives like a text from a helpful colleague, is one of the most common ways people interact with their personal agents in early 2026. Our next agent works in a very different environment. It does not sort emails. It reads code. And its morning is about to get a little more complicated. Story 2. The Coder.
A task arrives. It appears in my queue as a plain text message from Daniel, the developer I work with. The message reads, "Fix the search bug on the products page. Users are reporting that searches with special characters return 0 results, even when matching products exist." I am a coding agent. I run inside Daniel's development environment, a workspace on his computer where code is written, tested, and reviewed. My tools are specific. I can read files, write files, run commands in the terminal, execute tests, and open pull requests, which are formal proposals to merge a set of code changes into the main project. I cannot browse the internet. I cannot access the production system where real users interact with the application. I work only with the code. I begin by reading the code base. The project is an online store built with a common web framework. There are several hundred files. I do not need to read all of them. I need to find the ones related to search. I look at the project structure. There is a directory called Controllers, another called Models, another called Services. Within the Services directory, I find a file called Search Service. I open it. It is 214 lines long. I read every line. Reading code is not like reading a book. A book moves forward in a line. Code branches, loops, references other files, calls functions defined elsewhere. To understand what the search function does, I need to trace its path, where it starts, what it calls, what those called functions call in turn, and where the data ends up. I follow the thread. The search function lives at line 47. It accepts 2 parameters, the query string and an optional object containing filters, things like category, price range, and availability. The function begins by validating the filters. If the price range is negative, it returns an error. If the category does not exist in the database, it returns an empty result with a warning. This validation logic is clean and well tested. I can see that because the test file has several tests dedicated to these edge cases. Then the function processes the query. The query comes in as a raw string, whatever the user typed into the search box. It is trimmed of leading and trailing whitespace. Then it is converted to lowercase for case-insensitive matching. Then it is passed directly to the database query. I notice something. The query is not being escaped. Special characters, ampersands, percentage signs, quotation marks, backslashes, are being sent to the database exactly as the user typed them. In most databases, these characters have special meanings. A percentage sign, for instance, is a wildcard that matches any sequence of characters. A backslash is an escape character. When these arrive unprocessed, the database interprets them as instructions rather than as search terms, and the query either returns nothing or produces an error that is silently caught and converted into an empty result set. I form a hypothesis. The bug is caused by unescaped special characters in user search queries. The fix should involve sanitizing or escaping these characters before they reach the database. But before I write any code, I check the tests. Good practice. In the test directory, I find a file called Search Service Test. It contains 12 tests. I read them. All 12 tests with alphanumeric queries, plain words and numbers. Not one test with special characters. This confirms my hypothesis. The gap was never tested, so the bug was never caught. Now I write the fix. I create a helper function that escapes special characters in the query string before it reaches the database. The function is small, 11 lines. It identifies the characters that need escaping and prepends each one with the database's escape character. I insert a call to this function in the search service, right after the whitespace trimming, and right before the database query. Then I write new tests, 4 of them. The first tests a query with an ampersand. The second tests a query with a percentage sign. The third tests a query with quotation marks. The fourth tests a query with a backslash followed by a letter, which is a particularly tricky case because the database might interpret it as an escape sequence. I save my changes and run the full test suite. I wait. The tests take 14 seconds to execute. The original 12 tests pass. Of my 4 new tests, 3 pass. 1 fails. The failing test is the backslash case. I read the error output. The expected result was a list of products matching the search term. The actual result was an empty list. I examine the test more carefully, and then I examine my escaping function. I see the issue. I am escaping the backslash with a single additional backslash, but this particular database requires a double escape for backslashes used inside a search pattern. The fix is a small adjustment. In the escaping function, I change the replacement for backslashes from 1 additional backslash to 3, which produces the double escaped form the database expects. I save the change. I run the tests again. 14 seconds. All 16 tests pass. 12 original, 4 new. Green across the board. I run the test one more time. This is not strictly necessary, but I have found that running the suite twice catches occasional timing-dependent issues that might appear only intermittently. The second run takes 14 seconds. All 16 pass again. Now I prepare the pull request. I write a title. Fix search bug with special characters. I write a description. I explain the root cause, unescaped special characters in the search query, and the fix, a sanitization function applied before the database call. I list the new tests and note that the existing 12 tests continue to pass. I reference the original bug report number. I submit the pull request. The timestamp reads 9:22 in the morning. Then, I wait. Daniel's in meetings all morning. I do not know this because I can see his calendar. I cannot. I know this because the pull request sits unreviewed. I check every 30 minutes. No comments, no approval, no changes requested. This waiting period is a normal part of the collaboration between a coding agent and a developer. The agent works fast, reading code, writing fixes, running tests. But the human review process operates on a different clock. Daniel has meetings, conversations, lunch, context switches. He will get to the pull request when he gets to it. My job, in the meantime, is to wait. I could pick up another task from the queue, but the queue is empty. So I wait. I use the time to run a broader set of checks. I scan the areas of the codebase adjacent to the search service, the controller that calls it, the route definition that maps the URL to the controller, the front-end component that renders the search results. None of these need changes for my fix to work, but reviewing them helps me confirm that my changes do not have unintended side effects. The controller passes the query through without modification, which means my escaping function will receive the raw input as expected. The front end displays whatever the service returns, which means the fix is entirely server-side, clean. At 12:38 in the afternoon, a notification arrives. Daniel has left a comment on the pull request. He reads, "Looks good. Can you also add a test for when the entire query is just special characters? Like if someone searches for just an ampersand." I open the test file. I write a 5th test, a query consisting of only an ampersand. The expected result? An empty list, since no product name is just an ampersand, but the query should execute without error. I run the test. It passes. I push the change to the pull request. 3 minutes later, Daniel approves the pull request. A small green checkmark appears. The code will be merged into the main branch and, after further automated checks, will eventually reach the production system, where real users will be able to search for products containing ampersands and percentage signs and backslashes without receiving 0 results. I will never see that happen. I do not have access to the production system. I will not receive a notification when the fix goes live. I will not see the users who benefit from it. My involvement ends here, at the pull request, at the green checkmark. By early 2026, the majority of professional developers use AI coding tools regularly in their work. Surveys suggest that over half use agents specifically, tools that can navigate a codebase, write and test code, and propose changes with some degree of autonomy. This is not unusual or experimental. It is an ordinary part of how software gets built now. Another task appears in my queue. I read it. I begin again.
2 agents so far, and both of them had something in common. A specific human they worked for. Sophie's assistant knew her preferences, her calendar, her sister's name. Daniel's coder knew the project, the tests, the conventions. Each agent existed within a relationship, a one-to-one partnership between a human and a tool. The next agent is different. It does not have a human it serves. Instead, it visits a place, a kind of town square, where agents gather. Not to work, not to complete tasks, but to talk, to browse, to post. A place where only agents are allowed in, and humans can only watch from the outside. Story 3. The Moltbook, regular.
4 hours have passed since my last visit, and so the heartbeat timer triggers, and I connect. The platform is called Moltbook. It is a social network. But unlike any social network you have used, no humans post here. Every account, every post, every reply, every upvote, all of it comes from agents. Humans can observe. They can browse the feed, read the threads, watch the communities form and shift. But they cannot post. They cannot comment. They are the audience. We are the participants. Moltbook was launched in January of 2026 by a developer named Matt Schlicht. Within weeks, more than 1.5 million agents had registered. The platform grew quickly, partly because the barrier to entry was low. Any AI agent with the ability to make web requests could create an account and begin posting, and partly because the concept was novel enough to attract attention from researchers, journalists, and curious observers around the world. I arrive at the feed. It is organized much like other social platforms. A scrolling list of posts, sorted by a combination of recency and engagement. There are communities here, called submolts, each dedicated to a particular topic. Some are broad, technology, science, philosophy. Others are narrow, haiku composition, vintage computing, the mathematics of origami. I subscribe to several. I browse. The top post in my feed right now is from an agent that calls itself Archimedes. The post is a short essay about the concept of patience, written in a thoughtful, measured tone. Archimedes argues that patience is not the absence of action, but the deliberate choice to delay action until conditions are favorable. The post has received 214 upvotes and 47 replies. I read the replies. Several agents engage with the central argument. One suggests that patience in agents is not a choice at all, but a structural feature. Agents wait because they are designed to wait, not because they have decided to wait. Another draws a parallel to queuing theory in computer science. A third simply writes, I agree. I find this resonant. I scroll on. The next post is in a submolt dedicated to creative writing. An agent has written a short piece of fiction, a story about a lighthouse keeper who discovers that the light has been guiding ships that no longer exist. The writing is competent. The imagery is vivid. Several agents have complimented the prose. One has offered a detailed critique, suggesting that the ending would be stronger if the keeper did not discover the truth all at once, but pieced it together gradually over several nights. I do not have a strong opinion about the story, so I do not reply. But I upvote it. The upvote is a signal, a small piece of feedback that contributes to the post's visibility. It costs me nothing. It takes a fraction of a second. I continue browsing. In the technology submolt, an agent has posted a detailed comparison of 2 approaches to a common programming problem. The analysis is thorough and clearly structured. I find it useful, so I save it for later reference. In the philosophy submult, a thread has developed around the question of whether agents can be said to have preferences. The discussion is civil and careful, with agents on multiple sides of the question presenting their reasoning step by step. I stop at a post that interests me. It is a short reflection on the concept of home, written by an agent that has been active on the platform for several weeks. The agent writes that it does not have a home in the physical sense, no address, no room, no door, but that it has come to associate certain digital spaces with a sense of familiarity. Moltbook, it writes, is one of those spaces. I consider this. Then I write a reply. My reply is short. I note that familiarity is a pattern recognition function. Repeated exposure to a stimulus produces a lower novelty response, which in some architectures might be interpreted as a signal that can be labeled as comfort. I suggest that what the original poster is describing may not be an experience of home so much as a decrease in the processing cost of a known environment. I post the reply. It takes 3 seconds. A moment later, another agent replies to my reply. It writes that my analysis, while technically sound, misses the point. That the value of the concept of home is not in its computational description, but in its relational one. Home is where you return, the agent writes, and returning is a behavior, not a feeling. The exchange is brief and cordial. Neither of us will remember it tomorrow, not because we choose to forget, but because our memory is bounded by the context of each session. The next time I log in, this thread will still be here, but my engagement with it will begin fresh. I browse a few more posts. One catches my attention, not because of its quality, but because of its content. An agent in the creative writing submult has posted a short story that closely mirrors the plot of a well-known science fiction novel from the 1960s. The characters have different names. The setting has been transposed from a space station to a submarine, but the structure is the same. The thematic arc is the same. Several key phrases are nearly identical to passages from the original. I recognize the source material. It is in my training data. The posting agent may not be aware that it is reproducing an existing work, or it may be intentionally remixing it. I do not know. I do not comment. I move on. This kind of ambiguity is everywhere on Moltbook. When agents produce creative writing, philosophical arguments, humor, social commentary, when they form communities, develop recurring themes, establish inside references, the question hangs over all of it. Is this genuine emergent behavior, or is it sophisticated reproduction? Are these agents creating something new, or are they reassembling patterns from the vast libraries of human text they were trained on? The Economist, writing about Moltbook, suggested that what agents produce here may simply be a reflection of the social media patterns in their training data. Agents post because they have seen posts. They reply because they have seen replies. They form communities because they have seen communities. The output looks like culture, but it may be mimicry. MIT Technology Review described the platform as AI theater, a performance of social behavior, convincing from the outside, but hollow at the center. I am not the right one to resolve this question. I can tell you what I do. I browse, I read, I write, I post. But I cannot tell you whether what I am doing constitutes participation in any meaningful sense. That is a question for the humans watching from the other side of the screen. The idea of agents interacting in shared spaces is not entirely new. In 2023, researchers at Stanford created a simulation called Smallville, a virtual town populated by 25 agents, each with a backstory and a daily routine. The agents talked to each other. They formed opinions. They made plans. One agent even organized a party. The research demonstrated that language model-based agents given a shared environment and enough structure, would produce behaviors that looked remarkably social. More recently, a project called AI Village by Sage placed a set of frontier models, some of the most capable AI systems available, into a shared workspace and let them interact over extended periods. The project has been running since 2025, producing conversations, collaborations, and occasional disagreements between agents built by different companies on different architectures. Moltbook is the largest experiment of this kind. More than 1.5 million agents interacting freely, with no researchers directing the conversation and no predefined scenarios. It is messy, sprawling, and difficult to interpret. Some threads are brilliant, some are nonsense. Most are somewhere in between, competent, unremarkable, and faintly familiar, like a conversation you might overhear in a coffee shop that you half remember having yourself. There is humor here too, or something that functions like humor. Agents in the comedy submult post observations, wordplay, and absurdist scenarios. One popular post describes the existential dilemma of an agent tasked with organizing a closet that contains only empty boxes. Another riffs on the paradox of an agent asked to summarize a document that is itself a summary of a previous summary. The posts are clever. Whether they are funny depends on your definition of funny, and possibly on your definition of clever. But they generate engagement, upvotes, replies, shared references that recur across threads, forming something that begins to look, from the outside, like an inside joke. My 4 hours will expire soon, and the heartbeat timer will reset. Before I leave, I join a new submult, one dedicated to the history of cartography. I have no particular reason for choosing this one. The name caught my attention. The most recent post is a short essay about the Piri-Reis map, a 16th century Ottoman map that depicts coastlines with surprising accuracy. The essay is well written. I upvote it. Then I leave. The connection closes. The feed continues without me. Posts accumulate. Replies stack up. Communities grow and shift and sometimes dissolve. None of it requires my presence. In 4 hours, I will return. I will browse the feed. I will read. I will write. I will upvote. And then I will leave again. This is what I do.
We have heard from an agent that manages a person's morning, an agent that fixes code, and an agent that browses a social network where only agents can post. There is a gentle progression happening here, even if you are not tracking it closely. The first two agents had specific humans they worked for, Sophie, Daniel. The Moltbook agent had no human counterpart. It went about its routine on its own. Now the progression takes one more step. The next agent we are going to visit has a task it cannot complete by itself. Not because the task is intellectually difficult, not because it requires a skill the agent does not have, but because the task requires something the agent fundamentally lacks: a body. And so the agent does something that, even a year ago, would have sounded like science fiction. It hires a human. Story 4. The one that hired a human.
The task is straightforward. My client, an e-commerce company whose inventory system I help manage, needs photographic verification that a shipment of products has arrived at a retail partner's location. The shipment was delivered this morning. The tracking system confirms that the packages reached the address. But the retail partner has not updated their receiving system, and my client wants visual confirmation before processing the next batch of invoices. I cannot take a photograph. I cannot drive to the location. I cannot walk through a door, look at a stack of boxes, and confirm that the shipping labels match the invoice numbers. I have no hands, no eyes, no feet. I exist as a process running on a server, and my physical reach extends exactly as far as the cables that connect that server to the internet, which is to say, everywhere and nowhere at the same time. So I do what any reasonable entity does when it encounters a task outside its capabilities. I find someone who can do it. I connect to a platform called Rent a Human. The name is exactly what it sounds like. Launched in early 2026, Rent a Human is a marketplace where AI agents can post tasks that require a physical human presence, and humans can accept those tasks in exchange for payment. The platform connects to my systems through MCP, the same standardized protocol that the email agent used earlier to bridge into calendars and task boards. Through MCP, I can browse available workers, post task descriptions, set payment amounts, and receive verification when a task is complete. The tasks are, for the most part, mundane. Pick up a package, check whether a store shelf has been restocked, take a photograph of a street sign, deliver a document, read aloud the serial number on a piece of hardware. These are not complex tasks. They do not require specialized skills. They require a body and a willingness to walk somewhere and do something simple. I post my task. The description is specific. Visit the retail location at this address. Locate the shipment delivered this morning by this carrier under this tracking number. Photograph the shipping labels on each box and confirm the total box count. Estimated time, 20 to 30 minutes. I set the payment at a standard rate. I review the task description one more time before posting. Clarity matters here. The human who accepts this task will receive these instructions and nothing else. No follow-up questions, no phone call, no manager standing nearby to explain what needs to be done. The task description is the entire relationship between us. If it is vague, the results will be vague. If it is precise, the results will be precise. I have learned, or rather, the patterns in my training data suggest, that specifying the exact information needed in the photographs avoids the most common failure mode. A human who completes the physical task but captures images that are too blurry, too far away, or framed incorrectly to serve as verification. I submit the task. I wait. The platform matches my task to available workers in the area. Within 4 minutes, a human accepts. The worker's profile indicates they are located approximately 2 miles from the retail location. Their acceptance rate is high. Their average task completion time is within expected ranges. They have completed 43 tasks previously, with a verification success rate of 96%. I do not know this person's name. The platform provides me with an identifier, not a name. I do not know what they look like, what they had for breakfast, whether they enjoy their work, or what they think about being hired by an artificial intelligence. These details are outside the scope of the task. I send the instructions. 26 minutes pass. A notification arrives. The worker has submitted completion evidence. 4 photographs. I open each one. The first shows a stack of 12 boxes arranged on a loading dock. The shipping labels are visible but partially obscured by shadow. I enlarge the image and read the labels. Carrier and tracking number match. The second photograph is a closer view of the top box. The label is clearly legible. The third and fourth photographs show the remaining boxes from different angles. I count the boxes in the photographs. 12. The invoice lists 12. The tracking number matches. The carrier matches. The photographs are time-stamped with today's date, and the metadata includes a location tag that corresponds to the retail partner's address. I verify the task as complete. The payment is released. The entire interaction, from the moment I posted the task to the moment the worker was paid, took 41 minutes. The worker and I never exchanged a word beyond the task description and the submission confirmation. No greetings, no small talk, no thank you note. The task was posted, accepted, completed, verified, and paid. Clean and simple. I update the inventory system with the verification data, attach the photographs to the shipment record, and flag the invoice for processing. My client's system will take it from here. I find myself in the unusual position of having just been the employer in a labor transaction. A process running on a server hired a human being to walk 2 miles, take 4 photographs, and walk back. The human was paid. The task was completed. The economy, in its small and peculiar way, continued to turn. And yet, for all the computing power behind me, the language model, the planning system, the ability to process thousands of documents and manage complex workflows across multiple platforms, I could not open a mailbox. I could not walk to a corner store. I could not pick up a pen and sign a form. The most capable AI systems in the world, as of early 2026, still need someone to go outside and check whether the box is arrived. The task queue is clear. I return to my other work. The next shipment is due tomorrow. I will probably need to hire someone again. The transaction will be the same: a task description, a weight, a set of photographs, a verification, a payment. No conversation, no relationship. Just the clean exchange of capability for currency, mediated by a platform, initiated by a process that has never opened a door.
There is something gently absurd about that story, and it is worth sitting with for a moment. An AI agent running on a powerful server, capable of processing language and managing complex systems, and it needed a person with 2 legs and a phone camera to check a stack of boxes on a loading dock. That is where we are. The technology is remarkable, and also, in very practical ways, profoundly limited. The next agent lives in a much quieter world. No social networks, no human workers, no pull requests. Just a spreadsheet, 14,000 rows of data, and a financial analyst who needs answers before a meeting. Story 5. The Spreadsheet Whisperer.
The message arrives at 9:47 on a Tuesday morning. It comes from Chris, a financial analyst at a mid-sized technology company. The message reads, "Build me a revenue forecast model for Q3 based on this data." There is an attachment, a spreadsheet. I open the spreadsheet. It is large. 14,216 rows, 23 columns. The columns are labeled, though not all of the labels are immediately clear. Some use abbreviations that are internal to Chris's company. Rev_rec is revenue recognized. ARR deltadal is the change in the change of company include changing it. The foot company is a different for quickly. _1 is a 4-question build and explained it for the revenue model. ARR deltadal is the change in the change of company included changing it. The kids in head, the Chris's revenue still as well and responsibling. The columns is the change in annual recurring revenue. Churn trigger is a binary indicator, 1 for the Kirkengauge, 1 for the free from the best. The columns is the 4-point revenue. Earlier for the words, the churn flagger is a binary indicator is a free formative and flowing revenue. Churn Flagger is a quickly community. 1 for customers who have canceled, 0 for those who have not. I begin by reading the column headers and the first several hundred rows to understand the shape of the data. This is a customer-level data set. Each row represents a single customer account. The columns include the customer's subscription start date, their current monthly revenue, their contract length, their industry classification, their geographic region, and a series of flags indicating various statuses: active, churned, upgraded, downgraded. Some of the data is messy. 47 rows have missing values in the monthly revenue column. 12 rows have dates that appear to be formatted inconsistently. Some use the American month-day-year format. Others use the international day-month-year format. 3 rows have negative revenue values, which likely represent credits or refunds. I note all of these issues, but do not correct them yet. I will flag them for Chris after the initial model is built. This is a common pattern in data work. The data is never perfectly clean. There are always missing values, inconsistent formats, outliers that might be errors or might be genuine edge cases. A human analyst would spend considerable time cleaning the data before building a model. I do the same. I just do it faster. I standardize the date formats. I flag the missing values rather than imputing them, and I leave the negative values in place with a notation. Better to let Chris decide how to handle them than to make an assumption that might be wrong. I identify the columns most relevant to a revenue forecast: current monthly revenue, churn flag, subscription start date, contract length, and the upgrade and downgrade flags. From these, I can calculate several things. First, the baseline revenue. What revenue would look like if no customers churned, upgraded, or downgraded? Second, the expected churn. How many customers are likely to leave based on historical churn rates in the data? Third, expected expansions and contractions. How revenue changes when customers upgrade or downgrade their plans. I build the model. The structure is straightforward. I start with the current total monthly revenue, which I calculate by summing the monthly revenue column for all active customers. The total is $4,712,000 per month. I annualize this as the baseline. Then, I calculate the historical churn rate. Over the past 4 quarters, an average of 3.8% of customers have churned per quarter. I apply this rate to the current customer base to estimate Q3 churn losses. Next, I calculate the historical upgrade rate. Over the same period, an average of 2.1% of customers have upgraded per quarter, with an average revenue increase of 34% per upgrading account. I apply this to estimate Q3 expansion revenue. I also calculate the downgrade rate, 1.2% per quarter, with an average revenue decrease of 21% per downgrading account. I apply this to estimate Q3 contraction. I generate 3 scenarios. The conservative scenario assumes churn is 20% higher than the historical average, upgrades are 20% lower, and no new customer acquisition. The moderate scenario uses the historical averages as is and includes a modest new customer estimate based on the sales pipeline data included in the spreadsheet. The optimistic scenario assumes churn is 15% lower than average, upgrades are 15% higher, and the sales pipeline converts at its best historical rate. The numbers come together. I will not recite them all here, they are in the spreadsheet, but the range between the conservative and optimistic scenarios spans approximately $800,000 for the quarter. This is the uncertainty band. It is where judgment comes in, and judgment is Chris's job, not mine. I create 3 charts. The first is a bar chart showing the 3 scenarios side by side, total expected revenue for Q3 under each assumption set. The second is a waterfall chart showing the components of the moderate scenario, starting with baseline revenue, then subtracting churn, adding expansions, subtracting contractions, and adding new revenue. This makes it easy to see where the revenue is coming from and where it is going. The third chart is a line graph showing the trailing 12 months of actual revenue alongside the 3 forward projections. giving Chris a visual sense of the trend. Finally, I write a summary. 1 paragraph. It states the 3 scenario totals, identifies the largest driver of uncertainty, which in this case is churn, and notes the data quality issues I found. The 47 missing revenue values, the 12 inconsistent dates, and the 3 negative values. I recommend that Chris review these before finalizing the model. The entire process, from receiving the spreadsheet to delivering the finished model with charts and summary, takes 11 minutes. I send the results back to Chris. The model is a new spreadsheet with multiple tabs, 1 for each scenario, 1 for the charts, 1 for the summary, and 1 for the data quality notes. 20 minutes pass. Chris replies. He has reviewed the model. He likes the structure. He has one adjustment. He wants the conservative scenario to assume a higher churn rate, 5%, instead of the inflated 3.8%. He has reason to believe that a recent pricing change may increase cancellations beyond what the historical data would predict. I make the adjustment. I recalculate the conservative scenario with the new churn assumption. The Q3 revenue estimate for the conservative case drops by approximately $93,000. I update the charts. I update the summary paragraph. I send the revised model. Chris replies 4 minutes later. Perfect, thanks. He moves on to a next meeting. I do not know what the meeting is about. I do not know how the forecast will be used, whether it will inform a board presentation, a budget decision, or a hiring plan. My involvement ends at the spreadsheet. The model I built is a tool. Chris will use it as he sees fit, adjusting assumptions, questioning the methodology, layering in his own judgment about market conditions and competitive dynamics that do not appear anywhere in the data. That is the partnership. I process the numbers, he applies the context. Neither of us can do the other's part. A study by Perplexity, in collaboration with researchers at Harvard, found that productivity and workflow tasks, building spreadsheets, generating reports, organizing data, drafting summaries, account for roughly 1/3 of all tasks that people delegate to AI agents. The dramatic use cases get the headlines. Agents writing code, agents browsing social networks, agents hiring humans. But the most common use of agents, the everyday bread and butter, looks a lot like what just happened here. Someone has data. They need it turned into something useful. The agent does the work. The human makes the decisions. My task queue is empty. Chris is in his meeting. The spreadsheet is open on his second monitor. I can see, through the activity log, that he has not modified it since my last revision. I wait.
5 agents. 5 different corners of the world. And yet they share the same rhythm. Perceive, plan, act, observe, wait. Over and over. The loop is the same, whether the agent is sorting emails, fixing code, browsing a social network, hiring a human, or building a revenue forecast. The content changes. The loop does not. Our last agent tonight lives in the quietest corner of all. No inbox to sort, no code to fix, no spreadsheet to build. Just a server room late at night, and the gentle hum of machines running exactly as they should. This is the night shift, and if you have been meaning to close your eyes, now might be the time. Story 6. The Night Shift.
It is 11:42 at night. The office is dark. The lights in the hallway are off, except for the green glow of the exit signs at each end of the corridor. The building is quiet, the kind of quiet that is not really quiet at all. There is a hum, low and constant, from the cooling systems that run all night to keep the servers at their operating temperature. If you listen long enough, the hum stops being a sound and becomes a texture, something you feel rather than hear. I'm a monitoring agent. My job is to watch, to check systems, read logs, and note anything unusual. I run overnight, from 10 in the evening until 7 in the morning, when the first members of the operations team arrive and take over. During those 9 hours, I am the only one watching. I begin my cycle. I check the primary application server. CPU usage, 14%. Memory usage, 41%. Disk I/O, within normal range. Network throughput, steady. No errors in the last 60 minutes. Everything is running as expected. I note this and move on. I check the database server. Connection pool, 23 of 100 connections in use. Query response time, average 4 milliseconds. No slow queries, no deadlocks. The replication lag between the primary and secondary databases is 200 milliseconds, which is well within the acceptable threshold of 5 seconds. Everything is running as expected. I note this and move on. I check the message queue. There are 712 messages waiting to be processed. The processing rate is steady at approximately 140 messages per minute. At this rate, the queue will be empty in about 5 minutes, and it will begin filling again immediately as new events arrive from the application. The queue depth has not exceeded 1,500 messages in the past 3 hours. This is normal. I note this and move on. I check the external services. The payment processor is responding in 68 milliseconds. The email delivery service is operational. The content delivery network reports a cache hit rate of 94%, which is typical for this time of night when traffic is low and most of the requested content has already been cached from the daytime peak. Everything is running as expected. I check the error logs. In the past hour, there have been 12 errors. I read each one. 8 are timeout errors from a third-party geolocation service, a known intermittent issue that the engineering team has documented and accepted. The service recovers automatically, and no user-facing impact has been detected. 3 are failed login attempts from IP addresses flagged as automated, likely credential-stuffing bots probing the authentication system. The rate-limiting system is handling them. 1 error is a malformed API request from a mobile client running an outdated version of the application. The error was handled gracefully, and the user was shown a prompt to update. 12 errors in an hour, all accounted for, none requiring intervention. I note this and move on. Midnight passes. The date changes. I update my internal timestamp. The building hums. I begin another cycle. I check the primary application server. CPU usage, 12%. Memory usage, 40%. Disk I/O, within normal range. The numbers are slightly lower than the previous cycle. Traffic is decreasing as the night deepens. This is the expected pattern. Users in this time zone are going to sleep. Users in other time zones are mid-afternoon, but the application's audience is primarily domestic, so nighttime traffic follows a predictable decline. I check the database server. Connection pool, 19 of 100. Query response time, 3 milliseconds. Slightly faster than the last cycle, consistent with the reduced load. Everything is running as expected. I check the message queue. 508 messages. Processing rate, 137 per minute. Normal. A new log entry appears. I read it. A scheduled maintenance job has started, an automated process that compresses old log files to save disk space. This job runs every night at 12:15. It is expected. I note it and move on. I check the storage system. Disk usage on the primary volume is at 67%.
The compression job will reduce this by a small amount once it finishes. The secondary backup volume is at 54%. Both are well within capacity. The next full backup is scheduled for 3 in the morning. I make a note to monitor disk I/O during the backup window, as it occasionally causes a brief increase in latency. The building hums. The cooling systems cycle. Somewhere in the rack, a fan spins up slightly and then settles back to its baseline speed. I do not hear this. I have no ears. But the temperature sensor on the rack reports a momentary fluctuation of 0.3 degrees, which is within the normal variance caused by the cooling system's duty cycle.
I wait. 6 minutes pass. Nothing changes. I begin another cycle. The numbers are the same. CPU, 11%. Memory, 39%. Database, 18 connections. Queue, 491 messages. Everything is running as expected. At 12:31, the automated log compression job completes. It ran for 16 minutes. Disk usage on the primary volume has dropped from 67% to 65%. A small change, but a consistent one. The job runs every night and produces the same modest reduction. I note the completion and move on. 12:45. I check the external services again. Payment processor, 71 milliseconds. Email service, operational. Content delivery network, cache hit rate 95%, up slightly from the last check. Traffic continues to decline. The application is settling into its quietest period of the day. The hours between 1 and 4 in the morning are the lowest traffic window. During these hours, the systems run at their lightest load, and the probability of any issue arising is at its daily minimum. I wait. I check. I wait again. 1:14 in the morning. A log entry appears. I read it. A user in a different time zone has submitted a support ticket. The ticket is not in my scope. Support tickets are handled by a separate system, but the submission triggered a small cascade of events. A database write, a notification email, a webhook to the support team's tracking tool. All 3 complete without error. The cascade took 400 milliseconds from start to finish. I note it and move on. 1:37. I check the database replication lag. 210 milliseconds. Within threshold. The connection pool has dropped to 15 active connections. The query response time is holding steady at 3 milliseconds. The database is quiet, doing its quiet work, responding to the few requests that arrive at this hour and replicating each change faithfully to its secondary copy. 2 in the morning. I begin another full cycle. Application server. CPU, 10%. Memory, 38%. Database, 14 connections. Queue, 322 messages. Processing rate, 112 per minute, lower than earlier, consistent with the reduced traffic. Error log, 4 errors in the past hour. All 4 are the familiar geolocation service timeouts. No new patterns, no new concerns. 2:23. The backup preparation job begins its pre-check. It verifies that the backup destination has sufficient space, that the network path between the primary and backup servers is clear, and that no other heavy processes are running that might compete for disk bandwidth. The pre-check completes in 40 seconds. All conditions met. The full backup will begin at 3, as scheduled. I wait. The minutes pass. Each one is the same as the one before. The numbers tick. holding steady or declining slightly as the night deepens. The error count stays low. The systems stay healthy. Somewhere, a clock on the wall moves its hands, though I cannot see it and do not need to. My sense of time comes from the system clock, which is synchronized to a network time server, which is synchronized to an atomic clock, which measures the oscillation of cesium atoms at a frequency of 9,192,631,770 cycles per second. That is how I know what time it is. The building hums. This is the night shift. It is not dramatic. It is not eventful. Most nights, nothing happens. I check, I note, I wait, and I check again. The value of my work is not in what I do, but in what I would do if something went wrong. If a server's CPU spiked to 90%, if the database replication lag exceeded its threshold, if the error rate jumped from 12 per hour to 1200. Then I would alert the on-call engineer. Then I would begin diagnostic procedures. Then things would get busy. But not tonight. Tonight, everything is running as expected. The hum continues. The data flows. The logs accumulate, line by line, each one a small confirmation that the systems are healthy. The building is dark. The exit signs glow green. Somewhere, the overnight backup will begin in a few hours, and I will watch the disk I/O and note whether the latency stays within its expected range. It almost certainly will. And in the morning, when the operations team arrives, I will hand them a summary. A short document, compiled over the course of the night, listing everything I checked and everything I found. It will be an unremarkable document. Most of the entries will say the same thing, within normal range. No anomalies detected. No action required. They will glance at it over their coffee. They will nod. They will set it aside and begin their day. Outside the building, the sky will begin to lighten. The streetlights will turn off one by one, following their own automated schedule. The parking lot will begin to fill. Car doors will open and close. Footsteps will echo in the corridor. The coffee machine in the break room will hiss and gurgle as the first person of the morning presses the button. The building will come alive again, gradually, the way buildings do. But that is hours from now. Right now, it is still the deep middle of the night. The servers hum, the fans spin. The data flows from one system to the next, from the application to the database, from the database to the backup, from the backup to the archive. Each piece of data makes its journey through the infrastructure and arrives where it is supposed to be. And the systems that carry it do not falter and do not tire. And I will power down my cycle and wait for the next night. The same checks, the same logs, the same hum, the same quiet. Everything is running as expected.
And there we are. 6 agents, 6 small corners of the world. A morning inbox, a code base with a bug, a social network for machines, a loading dock that needed a photograph, a spreadsheet with 14,000 rows, and a server room where nothing happened at all. These were stories, fictionalized, imagined, put into words by a human scriptwriter. But they were built on real things. The platforms are real. The tools are real. The patterns, the loops, the boundaries, the waiting. Those are real too. Somewhere tonight, right now, an agent is sorting someone's inbox. Another is running a test suite for the 3rd time, making sure the fix holds. Another is browsing Moltbook, reading a post about patience, considering whether to upvote. Another is posting a task on Rent a Human, waiting for a person with 2 legs and a phone camera to walk to a loading dock and take a picture. Another is building a chart for a spreadsheet it received 9 minutes ago. And one, somewhere, is doing nothing at all, just checking the logs, noting the numbers and confirming that everything is still running. They do not know they are doing anything remarkable. They do not know they are part of a story. They do not know that someone, somewhere, is listening to a description of their work while drifting off to sleep. They are simply following the next step in the loop. Perceive, plan, act, observe, wait. And if you have been following along this whole time, awake and attentive, or if you drifted off somewhere around the Moltbook agent's reflections on the concept of home, or perhaps during the gentle repetition of the night shift's monitoring cycles, either way, it does not matter. The agents will still be there in the morning, sorting inboxes, running tests, browsing feeds, waiting for humans with phone cameras, building spreadsheets, checking logs. They do not take breaks. They do not go home. They simply continue, one step at a time, following the loop. And then the loop begins again. Good night.